This is module 19. We're going to be finding areas of triangles and parallelograms. One of the things that is really cool about parallelograms, we had an entire module on them, an entire unit on them, is the fact that they're basically like rectangles, but if you relocate a certain portion of it. So the bases of the parallelogram could be either pair of parallel sides. It really doesn't matter. It could be this here, it could be this here, but if I turned the parallelogram on its side, it could also be this here and this here. The only difference is there would be a different height for that parallelogram. So in this case, we have our bases could be these two blue lines. We also know the height. That's the shortest distance between the bases of the parallelograms, which means it's going to be perpendicular. Height, kind of like an altitude in a triangle. So the thing that's one of the reasons why I say it's a jigsaw is because if you actually were to relocate this triangle over here, you would actually make a rectangle here, which is kind of cool. So that actually plays into finding areas of parallelograms. So, but you need to know what the bases are and what the height is as well. So here is a postulate area of a square. Remember this from a previous module. Area of a square is basically the side length squared. You basically take the side length times itself. So that's area of a square. We also have our next postulate, which is going to be the area congruence postulate. And this is kind of one of those things that's a little intuitive. So if we know that two polygons are congruent, then they have the same area. You can actually prove that by transitive property. So there's your example there. Okay, so another postulate, again, because you're going to be using this, we're going to be figuring a lot of areas out in this particular unit. So postulate 26 is the area addition postulate. Remember, you had segment addition postulate, angle addition postulate. In this case, now we have area addition postulate. We have the area of a region is the sum of the areas of its non-overlapping parts. So in this case, where the area addition postulate comes in is that you might have to find multiple different areas for one figure to find out the total area that is covered. So we have area of a rectangle, area of a parallelogram, and area of a triangle. Area of a rectangle and triangle you guys have had before, and you've even had area of a parallelogram as well in middle school, but it's a little less prominent. It's used less often. So just to make sure, we have area of a rectangle is going to be base times your height. Your area of your parallelogram is exactly the same thing as a rectangle, because remember, if you relocate that triangle piece, you basically get a rectangle. So again, we have base times height. And the area of a triangle is going to be 1/2 your base times your height. Now, I'm going to be referring to this in other modules. It's little b times little h. Little b times little h, because when we get into 3 dimensions, you're going to have something that's called a big B, which is standing for the actual area of the figure, but we'll worry about that when it comes. But again, little b times little h gives you the area of each one of these figures, and then 1/2 of it would give you the area of the triangle. So let's get some examples, and again, there's multiple different ways of doing this, which is kind of cool. So it says use a formula to find the area. So what I notice is it tells us that we have parallelogram PQRS. So area of a parallelogram is 1/2, or is the base, little b, times little h. So you identify what your little b is and what your little h is. The cool thing is there's a couple different ways of doing this. Here's one. Little b could be 6, because that's on the floor here. So that's your base. And the height that is associated with that. And the height that is associated with that would be actually 8, because that's perpendicular to the opposite side, which means you'd have to extend this opposite side. So your height would be 8. And you get 48, and in this case we don't have any units, so we say units squared, or u squared. The other way I could do it is I could say my base, my little b, would be 12 if 12 was on the floor. But if 12 is on the floor, now your height, your h, the perpendicular segment would be 4. But again, it doesn't matter what way you pick. You're going to get the same either way. So we have 48 units squared. However you want to do it, it's up to you. Okay, so here's another one. It says find the perimeter and the area of the polygon. So the first thing we have to do is recognize that it is a parallelogram. So I'm going to fill in the missing parts. We got 20 and we got 30. So perimeter is pretty easy. You just add, you can do twice the length or twice the base in this case, you could also do twice the length of each leg, but I'm just going to do the 30 plus the 20 plus the 30 plus the 20 and go around. I started here and went around clockwise, or I'm sorry, counterclockwise. So when you do this, you add it, you get 50 plus 50 gives you 100, and it's units. That's for perimeter. For area, again, big B times little h, or I'm sorry, little b times little h. So little b in this case is the one that's on the floor, which is 30, and the one that gives you the perpendicular segment, or the distance between the two sides, would be 17. So in this case, you would have 510 units, and since it's area, it's going to be units squared. So be careful of your units. Okay, next one, we have find the perimeter and the area of the polygon. So again, perimeter, pretty straightforward, pretty easy. You just add 21 plus 10 plus 17. So we got 17 plus 21 plus 10 gives you 48. And then we have the area. And depending on how you look at this, I mean, they give us one height, which you need to make sure that you recognize that 8 is the height. Because a lot of times I see people just looking at 10 as the height because that's one of the ones that comes off the floor. But remember, it has to create a right angle. In this case, we don't have a right angle, so 8 has to be your height. So we have our height times our base, which is 21, and then you have to make sure you multiply it times a half. So 1/2 base times height, or 1/2 height times base. It does not matter because it's a commutative property. When you do this, we get 4. Multiply it, you get 84. And remember, units squared for here and units for here. And we're done. Okay, next example, we say, it says the base of a triangle is twice its height. The area of the triangle is 36 square inches. Find the base and the height. So in this case, we're trying to find out what actual h is, so we can plug it in and actually find out what the height and what the base is. So we know that area of a triangle is equal to 1/2 b times h. In this case, we know that h is our height. That's okay. But our b, in this case, is 2h. So we'd have to actually plug this in and solve it algebraically. So we'd have 1/2 2h times h. From Algebra 1, if you have two bases that have the same exponent, you add, two bases that have the same base, that is. So these guys have the same base, you would add the exponents. So we'd say a, the 1/2 and the 2 cancel out, so you'd have h squared. But in this case, we know that it's 36 square inches, is h squared. Get rid of the squared, you take the square root of both sides, you get plus or minus 6. But in this case, we only want the positive dimension. And then you plug it into each one of them to find out what your height is. So h we know is 6 inches. And your base would be twice that, which would be 6, or 2 times 6, which would be 12 inches. And that's it. Okay, this one's a little bit of a challenge and involves the addition postulate, the area addition postulate. You have two areas that you have to find out. You have basically the side of the barn has a rectangle here, so this is area 1. And then you have the top of it, the roof area is area 2. So it says you need to buy paint so that you can paint the side of a barn. A gallon of paint covers 350 square feet. How many gallons should you buy? So, first thing you need to do is you need to figure out what the area of the actual barn is. So, and we're just trying to do the side of the barn. Okay, so a gallon of paint we know is 350 square feet, so let's figure out how much area we have. So area 1, that's pretty easy, that's a rectangle, so we just do 26 times 18. Area 2 requires a little more thought. We know this is 26, and from previous modules we can actually see that this is a 45, 90 triangle. So there's one of two things that you can actually use. You can use trig, or you can actually recognize that the ratio going from a 90 degree, the hypotenuse, to a 45, opposite the 45 would be 26 divided by square root of 2. Okay, but again, if you use trig, you'd have to use either sine or cosine, depending on which one you were trying to find. But since it's a 45, it's an isosceles triangle, they're both going to be the exact same, 26 over square root of 2. Okay. So in order to find out what the area is, you have to do 1/2 your base, which we know if we kind of turned this triangle on its side, the base would be the 26 over square root of 2. The height would also be 26 over square root of 2. So that's kind of nice when you multiply it out because it gets rid of the square roots. And you need to add these two together. Okay, so if I added these two together, I would get 637 feet squared. So if we know the two areas add up to 637 feet squared, if we took 637 feet squared and a gallon of paint covers 350 feet, we would have to divide and find out that we have to round up if we're actually buying, so we'd have to buy 2 gallons of paint. Because again, you can buy a half a gallon, it would be in terms of quarts, but we're not going to look at that. We actually would need 2 gallons.